Good afternoon, ladies and gentlemen. We've all had that little irritating zing while we're trying to sleep, followed by a slap that you give yourself trying to get rid of a mosquito, only for it to return moments later. Now, there are many possible ways to control mosquitoes. Mosquitoes are a risk to humans more than they are a nuisance. For example, they may transmit diseases that they carry, such as Plasmodium species, causing malaria. Here you can see those red areas are, in fact, the areas in South Africa where Plasmodium or malaria may occur. Now, prevention of contact with the vector often prevents infection with the disease that they may carry. So, prevention of contact with mosquitoes will automatically prevent us from getting the diseases that they carry. Now, mosquitoes may reproduce in close proximity to humans. They may reproduce in your garden ponds, the little pond just out the door, or even your swimming pool. They may also reproduce in treatment wetlands, which are constructed and are, in fact, ideal breeding habitats and inevitably close to human settlements. Now, control of mosquitoes may be done in two ways. The traditional chemical way, aimed at adults and larvae, which may include DDT and other organofluorides, or biological methods, which are primarily focused on predation, which is especially effective against the aquatic stages of mosquitoes, such as the larvae or the egg rafts. Now, the biological control of mosquitoes may be influenced by the chemicals used in the environment, such as Roundup and endosulfan, which may change the behaviors or the anti-predator behavior of the larvae themselves. Fish often used in the predation or for the biological control of mosquitoes are, for example, Gambusia affinis and Clarias petragus. Invertebrates are Notonecta maculata, or the common backswimmer. These are just a few examples. Now, the use of Gambusia affinis as a biological control method may have adverse impacts on the mosquito population. For example, mosquito populations may become extinct locally due to them not being able to detect the predator and thus being preyed upon until the point of extinction. Or they may be able to detect the predator, such as the Gambusia affinis, and change their behavior and thus choose different oviposition sites. The mosquito fish are not the only predators of mosquito larvae or aquatic stages, but they are often used due to their aggressive predatory nature and highly tolerant nature, allowing them to survive and create populations or establish populations in almost any standing body of water. Now, species introduced as biological control may often become invasive or potentially negative to the environment. For example, Gambusia affinis may feed on native fish larvae. They may also outcompete native fish and disturb the planktonic balances, increasing turbidity, further reducing the habitat for the native fish. They may also be easily released into natural water bodies due to the fact that they are favored as aquarium fish. Now, for the study that I did as part of my honors subject, I compared the predation efficiency of invasive and native species on the predation on the mosquito egg rafts. Now, I also compared the predation efficiency of the native versus invasive species based on the mosquito larvae. And I identified the mosquitoes, or tried to identify the mosquitoes as they were reared from the egg rafts. Now, the hypothesis for this study was that a native fish species could, in fact, perform just as well as the invasive species in the control of mosquitoes. Now, the two native species used are those at the top. First is Pseudocorin labrus philander, or the southern mouth brooder, and the one on the right is the straight fin barb, or Barbus palladinosus. Now, like I said, these two represent my native fish species, and they are compared to Gambusia affinis, or commonly called the mosquito fish. The experiment consisted of all the individuals being starved for 72 hours prior to the experimental trial beginning. I chose 10 fish out of a possible 15 that I randomly selected or collected at the various points, and the fish were weighed and their body length measured, just to determine if this could in fact have a correlation with their predation. Mosquito egg rafts were used in the one trial. Now, this on the right is an example of a mosquito egg raft, while on the left you can see the larvae that were used. Now, the larvae were only used after a minimum of 3 weeks had passed, allowing them to reach a third or fourth instar stage based on their molting times. Now, the observations for the experiment were done in 15-minute intervals for the first 2 hours and for the next 22 hours and at hourly intervals. Thus, the total experiment consisted of a day, night, and a day period stretching over 24 hours. Now, this graph represents the average body weight for the 10 individuals used during the egg graft trial. Here it can be seen that Barbus paludinosus were the largest and Gambusia affinis the smallest of the three. The same relationship between the three species was seen for the individuals used in the larvae trial. The total egg grafts eaten per species over a 24-hour period. Now remember, this is the sum of egg grafts eaten for 10 fish. Each fish was provided with 3 egg grafts in their own experimental container. Thus, no interpredation could have occurred for one fish eating the items of another. Here it was seen that the native fish species, the Pseudocrine labrus philander, ate the most egg grafts, a total of 28 out of 30, while the invasive species, Gambusia affinis, only consumed 20 out of possible 30. The third, or the second native species, the third species used, the Barbus paludinosus, only consumed 12 egg grafts in total. Now, each egg graft consists of about 100 eggs, approximately. So 100 potential larvae could hatch from the egg grafts remaining after predation. Now, here is the results for the egg graft trial. Seeing that 2 species did in fact consume all the larvae they were presented with. One native species, the Pseudocrine labrus philander, and the invasive Gambusia affinis. The other native species, Barbus paludinosus, were again shown to not prey very much on the larvae at all, consuming only a total of 11. Now, the observational data were used to construct predation curves. Now, this is the predation curve as constructed for the egg graft trial. Here it can be seen that for the first 19 hours, Barbus paludinosus did not show any predation whatsoever, and then consumed the 12 egg grafts. A nighttime period is shown as that shaded area there. At the point where the nighttime period ensued, it was seen that Gambusia affinis had consumed a total of 13 larvae, thus had 17 egg grafts, thus had 17 remaining, and Pseudocrine labrus philander had only 12 egg grafts remaining. After the 24-hour period, or the light conditions were restored, it was seen that predation continued, and Gambusia affinis at the end consumed 20 larvae, and Pseudocrine labrus philander had only 2 egg grafts left. Excuse the previous larvae, it was meant to be egg grafts. Now, the predation curve for the larvae trial was as follows. Again, it was seen that Barbus paludinosus did not show any predation within the first 17 hours of the experiment. The nighttime period in both predation curves, as could be seen for the previous one as well, showed no predation whatsoever for any of the 3 species. The first 2 hours showed high predation rates for the 2 species performing the best, the Pseudocrine labrus philander and the Gambusia affinis, which necessitated the construction of a focused predation curve. But from this 24-hour one, you could still see that after 8 hours, Pseudocrine labrus philander had consumed 80% of the larvae, while Gambusia affinis had already consumed 100%. In fact, 7.5 hours were needed to consume all the larvae. Now, the focused predation curve showed us this. It was seen here that for the first 15 minutes, Gambusia affinis preyed actively on the larvae, and it was seen that they reduced the number of larvae by 80% in the first 45 minutes, after which no further predation was seen for the first 2 hours. Pseudocrine labrus philander were shown to prey constantly on the larvae, also reducing the numbers, and had 15 larvae left after the first 2 hours. Now, the third objective was to identify the mosquitoes. Now, the family level identification could be made based on the characteristics of the egg graft and the larvae themselves. Here it can be seen that egg grafts, or this one here, is a fragmented egg graft. Those little top shells are the operculums. Now, each egg consisted only of the fusiform egg shell, as I could call it, and the operculum itself. This, together with the characteristics of the larvae of having a prominent siphon and comb pecten-like structures associated with the rear of the larvae, as well as the angle by which they hung from the water surface, identified them as Culicinae. The help of an expert called Alan Kemp was used to identify the species level. Now, Culix was identified as the species. It was, however, we were unable to differentiate between Culix trifulatus, Culex trifoliatus and Culex decens, seeing as they don't differ much in the adult form. Now, statistical tests or Tukey's honesty test were just used to determine whether the results of the three predators varied significantly. Here it was seen that Pseudocrene labrus philander did in fact perform significantly better than Barbus paludinosus in the Graft trial, while it was seen that Barbus and Gambusia did not differ significantly, and as well as Gambusia and philander. Now, for the larvae trial, it was seen that both Gambusia affinis and Pseudocrene labrus philander differed significantly from the Barbus paludinosus, because as you remember, both the Pseudocrene labrus philander and Gambusia affinis consumed all their larvae, while Barbus only consumed 11. Now, the ultimate goal of control is to reduce the number of adult mosquitoes being able to emerge and become a nuisance or potential health risk to humans. Thus, we need to reduce the amount of adults by reducing the number of larvae surviving. Now, here it was seen that predation or control can in fact be effective by means of predation on aquatic stages. Now, the native fish species, Pseudocrene labrus philander, were shown to be less effective in predation on the larvae, but they still consumed 100% of the larvae within 22 hours. Thus, from a fourth install stage, mosquitoes need more than 24 hours to pupate and reach adult form, allowing us to make the deduction that no adults would have emerged if all the larvae were eaten, even at the fourth install stage. Now, in conclusion, the hypothesis that an invasive species are needed for biological control can be rejected in the case of Graft predation, seeing as a native fish species did in fact perform better than the invasive one. The invasive species, or Gambusia affinis, were shown to prey more effectively on the larvae, consuming them earlier, but the native species, like I just said, consumed all the larvae within a 24-hour period, preventing adults from emerging. Thus, the native fish species, or Pseudocrene labrus philander, were shown to be just as effective as our invasive one in controlling the mosquito populations. Thank you.